In this video, we'll learn how to find the distance between a point and a plane. Now we're given an example here. We're asked to find the distance between a point P with coordinates -14, -11, and 14, and the plane defined by the equation 4x plus 2y minus 3z equals to -4. Now to do this, we'll work in 4 steps. The first step, I'll just write step 1, we find a normal to the plane. Well, since our plane has equation 4x plus 2y minus 3z equals to -4, we can find the equation of the normal simply by looking at the coefficients of the x, the y, and the z. So we define our normal as n equals to 4, 2, and -3. And that's our first step done. Step 2, we need to find the equation of the line passing through the point P, which we were given in the question, and which is parallel to the normal to the plane, which we just found in step 1. So what we can do is we can define a direction vector for our line, and we'll define it as u, and we'll simply make it equal to n. That way we're certain that it is parallel to n. And so, since this line passes through point P, we can go ahead and say that the line that passes through point P and which is perpendicular to the plane has the equation r equals to the position vector -14, -11, 14, plus some parameter which we'll call lambda, times the direction vector 4, 2, and -3. And that's our second step done. In our third step, which I'll write step 3, we need to find the coordinates of the point of intersection of the line and the plane. And to do this, the first thing we're going to do is rewrite our line equation in its parametric form. So those would be 3 equations. The first is x equals to -14 plus 4 lambda. The second would be y equals to -11 plus 2 lambda. And the third would be z equals to 14 minus 3 lambda. We now have our parametric equations, and we need to substitute these inside the plane's equation. So that would be the equation that we were given inside the question, which I'm underlining now. So substituting these equations inside the plane's equation, we find 4 times -14 plus 4 lambda plus 2 times -11 plus 2 lambda minus 3 times 14 minus 3 lambda equals to -4. We now expand and simplify as much as possible in order to solve for lambda. So expanding this, we find -56 plus 16 lambda minus 22 plus 4 lambda minus 42 plus 9 lambda equals to -4. And now gathering like terms, we find -120 plus 29 lambda equals to -4. That leads us to 29. Lambda, of course, is equal to 116, and therefore lambda is equal to 116 divided by 29, which gives us lambda equals to 4. Now that we know the value of the parameter lambda, we can calculate the coordinates of the point of intersection, which we'll call q, by substituting lambda equals to 4 into the line equation. And that line equation is the one we found in step 2. So that would be r equals to -14, -11, 14, plus 4, since lambda is equal to 4, times 4, 2, -3. And calculating this, we find 2, -3, 2. So the point Q, the point of intersection of the line and the plane, has coordinates 2, -3, and 2. And that's our third step done. Our fourth and final step, step 4, is to calculate the length of the line segment PQ. And we have the coordinates of both points P and Q. Remember, we were given the coordinates of P in the question, and we've just found the coordinates of point Q. So we can now go ahead and use the distance of a line segment, or I should say length of a line segment, formula, and we can write PQ is equal to 2 minus negative 14 squared plus negative 3 minus negative 11 squared plus 2 minus 14 squared. And it's the square root of all that. Now, after calculations and simplifications, we find that this equals to 256 plus 64 plus 144, all of which are under a square root, which equals to the square root of 464. And we find that PQ is equal to 4 times the square root of 29. And so that's the distance of the point P from the plane. And using our calculator, we find that this is approximately 21.5 units of length. And there we go. That's how we find the distance of a point P from a plane in 3 dimensions.